Hello guys and welcome back to TechWolf. In this video we are going to create a simple network in Cisco Packet Tracer, and we will revise on everything what we have learned in previous tutorials of this Cisco Packet Tracer course. And the main purpose of this tutorial which I'm creating right now for you guys is so you understand everything in depth, as I will go through in depth and explain you everything what you need to understand about these things which we have learned. Firstly, we will understand IP addresses, how you can assign IP addresses, and how you can set up a subnet mask to the same network so all devices are on the same network. Secondly, we will have a look at ARP, or Address Resolution Protocol, and I will showcase how you can check ARP table on devices and how ARP works, or Address Resolution Protocol, which is also very simple, but I just want to go through it so you also understand it in depth. Then we will have a look at switch, how switch is using or storing MAC address table, and how MAC address table is changing when devices are communicating or broadcasting into the network. And then we will understand what is gateway and why we even need this gateway IP address. And then also lightly I will touch on one subject which we still haven't discussed in our tutorials, which we will deep dive in next videos, which is STP, or spanning tree protocol. So you have a good understanding what is spanning tree protocol in general, like not in technical terms, but in general what it is and why we need spanning tree protocol. So let's start by building our network topology, where we will have only one router, one switch, and we will have 3 PCs. In the left bottom corner click on network devices, and in second tab here on the left hand side select routers, and we will be using router 1941, and click anywhere on workspace. And we will add this way our router. I will make it a little bit bigger. Let's add a switch, and also make sure that in first tab here in the left bottom corner you are in network devices, and select here switches. And we will be using switch 2960, which is very first switch. So click on it and click somewhere on workspace. And now let's add 3 end devices, or 3 computers. So here in the very first tab select end devices, and make sure that in the second navigation here is selected end devices, and click on PC, and let's add 3 PCs. This will be our first PC. Let's click again on PC, our second PC, click on PC, and this will be our third PC, or third personal computer. And now we can change this name so it is easier to understand that this will be PC1. The first one we will call PC-1, then second one PC-2, and third one we will name PC-3. So now in next step what we will be doing, we will connect our devices by using connections, and here in the left bottom corner select on connections, lightning icon, and here let's connect these all devices by using copper straight through cable. Let's start by our router. Click on router and connect it to gigabit Ethernet 0/0, and this is the just port, or name of the port is gigabit Ethernet 0/0. This means that we have connected this cable to RJ45 port, which is called gigabit Ethernet 0/0, and then click on switch. And on switch let's connect this device to also gigabit Ethernet 0/1, which is here at the very bottom. So we have connected it. However, these two devices haven't established connection, as you know. Why it is happening from my previous videos, and we will establish this connection by configuring router. As you know, by default router needs to be configured so it establishes connection with our switch. And now let's connect these 3 devices. And many things here in this tutorial I'm also repeating, so like I mentioned in this tutorial I'm just going through everything what we have covered in previous videos. However, I am going in depth so you have a good understanding what we are doing here. So again, let's select copper straight through cable, let's click on switch, and let's add our first device to fast Ethernet 0/1, and this is also just a port on the switch, name of the port on the switch, which is fast Ethernet 0/, which is RJ45 connection. So let's click on it, and then let's click on PC, and let's connect PC to fast Ethernet 0 port. And as you can see on PCs or computers or laptops, mostly there is only one of these ports if there is not installed additional NIC or network interface card with another port. Mostly all of the laptops or computers will have only one this port by default. and even with new laptops they might not have this RJ45 port at all. So you will need to use some USB RJ45 port adapter to connect a laptop. So let's click on it, connect first PC, also copper straight through cable. Let's select switch, let's add fast Ethernet 0/2. Let's click on our PC, let's connect it. Let's click on again copper straight through cable, let's click on our switch and let's click on fast Ethernet 03 and let's click on our first device and let's connect it. So now we have created a very simple network, and this is the network which you wouldn't be using in your home environment because we are using switch. This could be a network which you would be using, for example, in office or in some classroom. As normally if you would be using a home router, then access point, switch, DHCP and router itself, that would be only one device and that would be called home router, because home routers or home environment you would not have a switch unless you buy a switch and you connect this switch to your router if you would want to do. However, in home environment you wouldn't do it, and that would be called like Soho environment or small office, home office environment. Once we have physically connected all these devices, as you can see we have switch and we have router, these are network devices, and we have 3 computers which are end devices or user devices. So first thing what we will be doing is we will be assigning IP address. But before we be assigning IP address, first we will add nodes. In the top left corner, let's click on place node and let's add nodes of IP addresses on all devices to which we need to assign IP addresses, and first one will be a router. So let's click under our router and let's type in IP address which is 192.168.1.1. and as you know from previous videos where I was explaining what router is about, so router is about connecting networks. Router is not about connecting devices, for example computers or providing Wi-Fi access, but the main purpose of the router as a networking device is to connect different networks together. For example, if we would build another network to the right, then this router would connect this another router and we would have 2 IP addresses on a router, where this first IP address which we are adding here for this network, that would be the gateway to all these devices which are on this network, as all devices which are in local area network which we are creating, they have only one gateway address, and that gateway address is that router's address, and all these devices in this particular network are communicating to router if they want to reach out to some other networks, or for example if they want to reach out to internet. However, if you would want to create just a local area network here and you wouldn't need these devices to connect to other networks, then you don't even need to use a gateway address. Like I mentioned, gateway address on the computer devices are used only to communicate to the router, so these devices can communicate to other networks, and this is the main purpose of the router, to allow local area network devices or some devices in some particular network to talk to other networks. In this scenario, this router address or this gateway address wouldn't even be needed, and this router's gateway address, as you can see, this is class C IP address. In general there are 5 classes, but all classes which you need to know is class A, class B and class C. If you haven't studied them, then go through and check out what are IP classes. So class A IP addresses start with 10, class B IP addresses start with 172 and class C IP addresses start with 192. And there are also APIPA addresses or automatic private IP addressing, and this means that if the devices doesn't find the DHCP server, they assign IP addresses to themselves, and those APIPA addresses usually are starting with 169.254. And I will also demonstrate you how this works in this network. Before we assign IP addresses, we will make these devices to assign APIPA addresses to themselves, because we will make these devices to search for DHCP server, and once they will not be able to find the DHCP server, they will assign APIPA addresses to themselves. And like I mentioned, IP addresses start with 169.25. This is also important to know. So there are 4 classes of these IP addresses. There is class A, class B, and class C. And you need to know how to spot them when you are pinging devices or when you are using ipconfig command on some particular device, and you need to see them straight away and recognize straight away, because you need to understand on what type of network you are on, whether it's class A, class B, class C. Like I mentioned, class A starts with 10, class B starts with 172, and class C starts with 192, and the IP addressing starts with 169.25. Now let's add more nodes under our other 3 PCs. Let's click on node, and under first PC let's add a node, and we will be assigning the same IP range, which is 192.168.1.2. Let's do exactly the same under our second PC, 192.168.1.3, and under our third PC let's also add a node, 192.168.1.4. and as you know, switch doesn't need any IP addresses, as the main purpose of the switch is to allow devices to communicate with each other, and in comparison to router, the main purpose of the switch is to connect devices, and it is connecting devices based on MAC addresses, on device MAC addresses, which are built into each device. So router is connecting networks based on IP addresses, and switch is connecting devices based on their MAC addresses. So let's return back to our IP addresses. Like I mentioned, we have 3 classes of these IP addresses: class A, which starts with 10, class B, which starts with 172, and class C, which starts with 192, and then we have a IP addresses. And now let's have a look how a IP addressing works. Let's click on this our first PC, and let's go into desktop, and let's click on command prompt. And here let's type in ipconfig. And ipconfig command is used to see the details on that device. As we opened our PC1, we want to see what IP addresses, what configuration is in this particular device. That's why we in networking we use ipconfig command. Typed it incorrectly, so ipconfig, and hit enter. And here we can see more information about our device. We have this IPv4 address, which are these 32-bit addresses. These are 4 numbers which are separated by dots, and each of this number and IP address represents 8 bits. This means that each IP address is 32-bit long, where IPv6 address is 128 bits long. And here, once we have typed ipconfig, like I mentioned, this is the command which is used in your own computer to see information about your computer, about network settings. Here we can see that we don't have IPv4 address, or we don't even have any default gateways here. And if you would want to see even more information than this, you can use the command ipconfig/all. So let's have a look what we can see if we type in ipconfig space / and all. And if we click here, we can see much more information about this particular computer PC1. Here we can see physical address, and physical address is MAC address. This is the address which is burned into any PC or any computer, and there might be even more than 1 MAC addresses on one computer. For example, if you have 2 NIC cards or network interface cards, then for each network interface card you will have a separate MAC address, and MAC addresses are 48-bit long addresses. Another thing which you can see by using command ipconfig / all is also you can see DNS servers to which is this particular device connected. And as you see, this is also not connected to anything. So we need to configure all this information. But before I even start configuring these IP addresses, I will show you a PIP address. So let's open a computer, click into the desktop, and click into the IP configuration. This is where we can configure IP addresses, and as you can see, by default it is set to static. This means that we can manually assign addresses, but in real world scenario what would be happening: IP addresses, subnet masks, default gateway, DNS server even will be assigned by DHCP server to particular device. And DHCP server is domain host control protocol, which is assign IP addresses. And as you can see, I clicked there DHCP server, but we don't have in this network, as you see, we don't have here DHCP server. If you would be using a home router, then DHCP, like I mentioned, is built into the home router. So as access point is built in modern home routers. But in this router, there is no DHCP built in. This means that if DHCP or domain host control protocol is enabled on some particular device, it will be searching for DHCP server. If it will not find DHCP server, it will assign IP address to itself. As you can see, once I clicked into the DHCP, it assigned IPv4 address to itself, and this is a PIPA address, which I was mentioning earlier on, and it assigned IP address 169.254. And these are the IP addresses. Like I mentioned, you need to know how to spot straight away when you are trying to troubleshoot some networks. So let's click again onto this second PC. Let's go into command prompt and let's type in ipconfig and hit enter. Again, wrong information, ipconfig, hit enter, and now we can see that our IPv4 address in our scenario is 169.254, and this is what you need to spot straight away as, for example, network engineer. If you are trying to resolve some network connectivity issues and you don't understand why this or that device is not able to connect to network, maybe this could be disconfigured DHCP server, or DHCP server went down, or device is not able to communicate to DHCP server. And once the device is using this PIPA address, which starts with 169, which this device is assigning to itself, this means that this device, even if it will have a default gateway, it will not be able to communicate to outside network through router, because devices which have assigned to itself these PIPA addresses, they can communicate only with each other and on the same network. Now let's click on first PC, let's go into IP configuration, let's click into the DHCP. So this device will assign IP address to itself. We can check it by clicking again on this PC, clicking in command prompt, and here let's type in a command ipconfig and hit enter. And now we can see that this device assigned to itself 169. It has assigned to itself a PIPA IP address. So now let's click on this one. Let's type in ipconfig, hit enter. And this device or second device also have assigned to itself a PIPA IP address. Now let's try to ping from this device, which ends with .114.64. Let's try to ping this our first device. Let's go in, which ends with .39.20. So let's close this, let's open this device, and now let's ping 169.254.39.20. So we're pinging from our PC to our first device. Let's hit enter. And as you can see, pinging is going through. And to wrap this PIPA addressing, this means that the devices with self-assigned PIPA addresses, they are able to communicate with each other, but they will not be able to communicate outside the local area network, because devices which have assigned the PIPA addresses can't communicate outside local area network. Like I mentioned, I am just going in depth in everything in this particular tutorial, so you have a good understanding about everything what we have covered previously. So next step, let's assign IP addresses to all these three computers or all these three devices. Let's click on first one, let's click into IP configuration, and now hopefully you understand why we don't use DHCP, we use static, and we will be assigning this IP address, which is class C IP address 192.168.1.2, and click into subnet mask. Subnet mask 255.255.255.20, so they are on the same subnet, and we will not be using default gateway yet, but if you want to connect outside the network, you can also enter a default gateway. If you want these devices to communicate only inside the particular network or local area network, you don't need to specify any default gateways or any DNS servers, because that is not needed, because these devices are communicating within the network. Or for example, DNS server you could specify if you would have some domain server server within that local area network. As I have been creating a video on Active Directory and Windows servers, there you have a good understanding why we are using DNS server if we are connecting, for example, inside the local area network. Let's close this down and let's assign IP address to our second computer. Let's go into IP configuration and also static, and let's type in 192.168.1.3 and also click into subnet mask, and let's close this down and let's click into our shared device. Click into desktop, IP configuration, and also make sure that it is static 192.168.1.4 and click into the subnet mask and close this down. So now we have assigned IP addresses. However, what we can see here that our switch and router is still not able to communicate, and they still haven't established the communications. So next thing what we will be doing, we will be configuring this port on this our router. As you remember, on this router we use the port gigabit Ethernet 0/0 to connect this switch to our router, and here to configure our router, to assign this IP address to our router, which will be acting as gateway address. We can do it in two ways. First one is here in Cisco Packet Tracer. If you click on router, get into this config tab. This is the second tab, and here you will see this interface. And we have two interfaces, gigabit Ethernet 0/0. If we click into it, we can configure this, and we have another one which is gigabit Ethernet 0/1. But we will need to configure this gigabit Ethernet 0/0 on this router RJ45 port, to which we connected our switch. Here in Cisco Packet Tracer we can do it in two ways. Whether we click just on router and we click here in interfaces gigabit Ethernet 0/0, and we can click here simply on, and here we add IPv4 address, and here we can also add subnet mask. But what we will be doing, we will not be doing this easy way. As you can see, if I switch off, then connection is not established. If I click on, then this connection is getting established straight away. But what we will be doing, I will show you, like in my previous videos in this Cisco Packet Tracer course, how we can do it using CLI, or how we can enable this gigabit Ethernet 0/0 port by using command line interface or CLI. If we click here on third tab on CLI, first thing click enter.